Okay, continuing on with 13.3, number 2. You want to remember this note that we can have it written in radical notation with power here, or we can write this as a rational exponent. So using that rule can help us simplify these next 3 problems. A nice way to handle this problem is to look at this as a rational exponent, and we can write that as x to the 3/5, to the 5/3, and then x to the 4/3. Then we can apply our power rule here. When we are multiplying like bases, we add the exponents, so we get 9/3, and then that simplifies to x to the 3rd. Next up, we can write these as rational exponents. Also, we can write this as x over 6/3 and x squared. Okay. Then we can simplify these. This would equal x squared, and then this would just equal x. And we can apply our, we can do some canceling here. We can apply the subtraction rule, but we're going to get 1x on the top to cancel out. And so we're going to, a visual of that is, on top you have an x, on bottom you have this. You can cancel out one of the x's, so we have just x remaining. Okay. And then next up, let's write this one under the big radical sign here as y to the 1/5. Okay. And then we have the 4/3 of that. So using this rule over here, we can go like this, and we can say, okay, this is going to be the numerator, so I have 1/5 over 4. Now that's a complex fraction, but it's 1/5 divided by 4. And so when we think about that, it's 4 over 1. We could flip this up. Remember the division of fractions rule, and we can multiply by 1/4. So what I get is y to the 1/20. If you do a bunch of these, you'll see a shortcut for it, but that should help you get started with that. Thanks.